All right, so this is the second part of the video lesson 10.1. So the vertex form equation is this one here, and the vertex has coordinates of h and k. So write the equation in vertex form given the vertex and a point on the graph. So since this is the vertex, then this is the value of h and this is the value of k. And this is just any point on the graph, so this is the x value and this is a y value. So what I'm going to do is what we've done before. I'm going to substitute for y, x, h, and k. Okay, and that'll help us find the value of a. So then instead of y, -2. That's the y value. A is what we don't know, so that's the unknown. And then we know this is x, so x is 1 minus h. H is a -3, so we have a negative in front of a negative. That means this becomes plus. Take the square, and then plus the k value. The k value is 6. Okay, then simplify. So -2 equals, this is a. 1 plus 3, that's 4. So 4 squared plus 6. Then I'm going to subtract the 6 from both sides so that I can get the this expression by itself. So then this becomes -8. And when I take the square of 4, that's equal to 16. So this is 16a. Since I'm solving for a, I'm going to divide by 16 on both sides of the equal sign. And -8 over 16 simplifies to -1/2. And that's the a value. Okay, so then the equation of a parabola, an equation of this parabola is the following. So y equals a is -1/2, and then x minus h. H is -3, so this becomes plus 3 square plus k, which in this case is 6. So this is an equation for this parabola. Okay, so the next example, again we need to find a. So then y is 1 equals a is the unknown. X is 0 minus h in this case is -2. So again, this becomes plus 2 square, and k for this one is 6 again. Okay, so then 1 equals a times 2 square plus 6. Again, I'm going to subtract the 6 from this side and also from this side. So then this becomes -5 equals 2 squared is 4, so for a. Then since I'm trying to find the value of a, I'm going to divide by 4, which means -5 fourths is equal to a. So once we know the value of a, we can use the vertex, given vertex here, and write an equation for this parabola. So a is -5 over 4, open parentheses, x minus h, which is positive -2, so plus 2 square plus 6, and this is the equation for that parabola. So I hope this is not too bad. I know you've done this before, and hopefully it'll come back. Okay, all right, so for the next part, for the next problem, what we're being asked to find is the zeros. Okay, so this is where the graph crosses the x-axis, and notice that this is a parabola. So what I am going to do is notice this is the y value. Okay, so I can go to y equals again, and then just enter this equation. So I'm going to press, let's see, 3x squared minus 5x minus 4. Okay, understanding that the y value is 0, that's always a y value at the intersection of the x-axis. And that also explains here y is 0. Then I'm going to graph it. And after I graph it, I'm going to press second trace. I want the 0, right? So then I'm going to press number 2. So I'm going to press number 2 for this one. And let me just write that down so you have it on your notes. So these are the keys we press. Okay, so y equals second, y equals enter the equation, second trace, and 2. So I'm going to press the number 2 here. Then this is asking me the left bound. That means before the graph crosses the x-axis. So above the x-axis on this side, and after it crosses the x-axis, so that's there. And then it tells me that the 0, you find the 0 where x is -0.5906. So I'm going to round this to 2 decimal places. So one point of intersection is, okay, -0.59, comma 0. And the other point of intersection is, let's get that one. So second trace 2 again. But now let's get to the other intersection. So when we're below the x-axis, press enter and then get above it and press enter again. And it gives us 2.257. So I'm going to round that 5 to a 6. Okay, so this is 2.56 comma 0. And there are the zeros, roots, x-intercepts, solutions to this quadratic equation. All right, let's move on to the second example. The next example. So for this one is saying solve each quadratic by factoring. So I'm going to jump this to the other side because we're supposed to have a 0 because we're trying to find the zeros. So then this is 2x squared minus 8x. Then let's see for this one. There is a GCF, right? So there's a GCF of 2x. So 2x, and then this becomes x minus 4 equals 0. And for this one, I'm going to set the two factors to equal to 0, meaning 2x equals 0, and the other is x minus 4 equals 0. For this one, divide by 2, and for this one, add 4. So then for this one, 0 divided by 2 is 0, and for this one, x equals positive 4, which means the solutions to this equation are 0, 0, and 4, 0. And there we have the roots, solutions, x-intercepts for this problem. Okay, next one. For this one here, there's a GCF because 3 goes into 30 and 75. So then 3 comes out. Now this becomes x squared minus 15x plus 25 equals 0. Okay, so for this one, I'm going to divide by 3 right away. You can do this right away. So then we have x squared minus 15x plus 25 equals 0. Then you need to find multiples of a times c, being a being 1 and c being 25. So multiples of 25, that when we add those multiples, they add to a 15. Now the question is, do they exist? And I think I made a mistake here because this shouldn't be a negative 15, right? It should be dividing 30 by 15 should be 10. So I'm going to correct that real quick. I just fixed that. So now we need to find multiples of 25 that add up to 10. And I think you'll see it. It's 5 times 5 is 25. But since they have to add to negative 10, then they're both negative 5. Okay. So then this factor says x minus 5 times x minus 5 is equal to 0. So then what we can say is we take one of them and set it equal to 0 and solve for it. So when we solve for it, what we need to do is add the 5. So then we find that x is equal to 5. But notice we have two of them, so don't forget what that means. So solution is, I'm going to give you the point of intersection of the x-axis, or the x-intercept. X is 5 and y is 0, but what's special about this is that we have two of them, which means this is a double solution. So we should be able to see the graph only touching the x-axis and bouncing right off of it. So that's example number 7. Okay, example number 8. For this one, I'm going to jump this 4 to that side. So then we have 2x squared plus 9x plus 4 equals 0. Now notice there's a GCF here. So this is one of those that you do factoring by grouping. So I need to find the multiples of a times c, a being 2 and c being 4. So 2 times 4 is 8. And then I need to find the multiples of 8 that when I add them, they add to a 9, right? So then that's simple because if I multiply 1 times 8, I get 8. And if I add 1 and 8, I get 9. So then 2x squared plus 8x plus 1x plus 4 equals 0. From these two terms, I can factor out a GCF of 2x. And from these two terms, I can factor out a positive 1. Okay, so then this is 2x times x plus 4 plus 1 times x plus 4 equals 0. So then we have x plus 4 in common. So let's factor that out and then put together 2x plus 1. Now, once we have the linear factors, we set each one of them equal to 0, meaning x plus 4 equals 0 and 2x plus 1 equals 0, which means for this one, x equals negative 4, which means one point of the intersection of the x-axis or x-intercept is negative 4, 0, and the other, I'm going to subtract I'm going to jump and divide. So I'm going to jump the 1 to this side. So then this becomes -1. And then divide by 2. So the other point has coordinates of -1/2 and 0. So these are the 2 points of intersection for this graph. Okay. Thanks for watching. I'll see you in the classroom. Bye-bye.